In the summer of 1847, on a forested slope overlooking a small creek in the farthest northeastern corner of Pennsylvania, a stonecutter named Patrick Hennessy hammered a steel wedge into a face of bluestone and felt the rock break clean along its natural bed. He was one of several hundred Irishmen laboring at a quarry less than a mile from a construction site that would become the longest and tallest masonry railroad viaduct in the United States. The stone he was cutting was the very stone destined for the very arch that would rise above his head. The engineer who had designed that arch was 35 years old and had never built a viaduct in his life. The railroad footing the bill was $3 million in debt and would go bankrupt twice before the viaduct ever carried a single train. And still, the stone Patrick Hennessy pulled from that hillside in the summer of 1847 sits in the arch to this day. The viaduct remains in service. Freight trains roll across it every week. I have gone through the original engineering reports, the construction cost ledgers, the newspapers printed in Susquehanna County in 1847 and 1848, the cemetery records from Lanesboro, Pennsylvania, and the engineering histories of the New York and Erie Railroad. What emerged is the story of how an almost bankrupt railroad built something that should have been far beyond its reach, using stone cut from a hillside by men whose names the official record mostly failed to preserve. In 19 months of labor that produced a structure so precisely engineered, it has never once had to be rebuilt in 177 years. If the men who built this country with their bare hands matter to you, subscribe to Forgotten Labor right now. Hit the button, then come back. The New York and Erie Railroad was chartered in 1832, tasked with linking the Hudson River at Piermont, New York, to Lake Erie at Dunkirk, New York. The route stretched 447 miles. It crossed the Delaware River, then climbed the northern tier of Pennsylvania through the endless mountains of Susquehanna County, then dropped back into New York and ran across the southern tier to the lake. The Susquehanna County stretch was the brutal part. The mountains in that pocket of Pennsylvania are not high, but the creek valleys carved between them are deep and narrow. At a tributary of the Susquehanna River known as Starrucca Creek, the valley falls 110 feet below the surrounding grade. The railroad could not detour around it. The railroad could not descend into it and climb back out without grades too steep for any working locomotive. The railroad had to span it. The men who had to work out how were the engineering corps of the New York and Erie Railroad, operating under the railroad's chief engineer, Benjamin Wright, who had learned his trade on the Erie Canal back in the 1810s, and under Wright's principal assistant for the northern Pennsylvania section, James P. Kirkwood. Kirkwood was born in New York City in 1807 and trained as a civil engineer on the Long Island Railroad and on survey assignments across New England before joining the Erie Railroad in the early 1840s. He was 40 years old when ground was broken at Starrucca Creek. He was the engineer who would be on site every single week of the 19 months it took to raise the viaduct. The man who designed it was Julius Walker Adams. Adams was born in Boston in 1812 and trained under his uncle, the civil engineer Azel Ames, before setting out on his own in the 1830s. He had built modest masonry culverts and cut stone bridges on earlier railroad jobs in New England. He had never attempted anything on the scale of what the Erie Railroad needed at Starrucca Creek. Adams was 35 years old when the commission reached him. He spent the winter of 1846 and the spring of 1847 drafting a viaduct 1,040 feet long and 110 feet tall, crossing the creek valley on 17 masonry arches, each arch spanning 51 feet of open air. The entire structure engineered to carry double-track railroad loading. These two men, Adams designing at his drafting table and Kirkwood driving the work in the field, are the closest thing this project has to architects. What they built together, on the backs of laborers whose names have mostly vanished, is the reason a working railroad still crosses Starrucca Creek today. For perspective, consider what already stood in 1847. The Sankey Viaduct in England, completed in 1830 for the Liverpool and Manchester Railway, was 600 feet long and 70 feet tall. It was hailed as one of the great engineering triumphs of its age. The Starrucca Viaduct, once finished, measured 1,040 feet long and 110 feet tall, nearly twice as long and nearly twice as tall. And it was raised not in industrial England with its century of canal and railway know-how, but in a mountain valley in northeastern Pennsylvania by a bankrupt American railroad relying on horses, wooden derricks, hand tools, and Irish immigrant labor.
Why they chose stone instead of wood is the first question worth answering. In 1846, the New York and Erie Railroad had almost nothing in its coffers. The company had been chartered in 1832, had begun construction, had run dry of funds, had issued fresh stock, had borrowed against revenues it had not yet earned, and was surviving on a permanent financial knife edge. The decision to build the Starrucca Viaduct from stone rather than timber was not a decision born of wealth. It was a decision born of survival arithmetic. A wooden trestle at Starrucca Creek would have been cheaper to raise and quicker to finish. A wooden trestle at Starrucca Creek would also have demanded rebuilding within 20 years and required a permanent fire watch on every train that crossed it. At 110 feet of vertical exposure on a double-track main line, the replacement cost of a timber trestle at Starrucca was a recurring expense the Erie Railroad's financial officers concluded they simply could not stomach. Stone was chosen because stone endured. Stone did not burn. Stone did not rot. And the stone lay right there beneath the hillside beside the construction site. The Starrucca Creek Valley rests on a thick deposit of Pennsylvania bluestone, a dense, fine-grained sandstone that cleaves into regular rectangular blocks along its natural bedding plains and holds its form under compression for centuries. Julius Walker Adams studied the geology and made the only choice that made economic sense. They would cut the stone where it lay and raise the viaduct from the creek bed upward. The core engineering element of the Starrucca Viaduct is the arch. A masonry arch is a run of wedge-shaped stones called voussoirs, set in a curve from one pier to the next, each stone bearing against the one beside it. The entire run locked at the summit by a central stone called the keystone. The arch works because it turns the downward load of whatever rests on top of it into outward thrust at its base. So long as the two piers at either end resist that outward push, the arch stands. If the piers give way, the arch falls with them. The Starrucca arches each span 51 feet. Each arch climbs 25 feet above its spring line, the point where the curve begins above the top of the pier. Each pier is 12 feet wide at the base, tapering slightly as it rises, with a pointed cutwater on the upstream face to part the creek's flow. The piers were raised from the creek bed to a height of roughly 85 feet before the arches began. Then 25 more feet of arch above that, then the spandrel walls and the deck. The total height from creek bed to rail came to 110 feet. Every stone in those piers and arches was cut by hand from the quarry 800 yards up the hillside. The quarry crews worked with a method stonecutters had relied on since Roman construction gangs raised the aqueducts of Gaul. They drilled a line of holes along the stone's natural bedding plane using a handheld steel drill and a striking hammer, working in rotation, one man holding and turning the drill, one man swinging the hammer. Into each hole, they set 3 steel wedges, 2 thin outer pieces called feathers and a central plug, and drove them in sequence with a heavy hammer, each strike biting slightly deeper than the last, until the mounting pressure split the rock cleanly along its natural bed. A skilled stonecutter working the bluestone at Starrucca Creek could split roughly 8 to 12 rough blocks a day. A rough quarry block weighed between 400 and 1,200 pounds, depending on its size. The quarry crew loaded the rough blocks onto wooden sleds, and the sled teams hauled them down the slope to a cutting yard at the foot of the hill. The dressing yard was where the precision work took place. A finished stonecutter working bluestone with a steel chisel and a wooden or iron mallet could dress roughly 4 to 6 block faces a day to the required dimensions. The voussoirs for the arches called for the most exacting work on the whole project. Each voussoir had to be cut to a precise wedge angle so that when it was laid in the arch ring, its faces met the stones on either side across their full surface, transferring load evenly with no gaps. A voussoir cut a degree off would concentrate stress on one edge and crack under load. The stonecutters checked each one against a wooden template until the angle was exact. If a voussoir was cut even slightly wrong, the arch would not close cleanly at the keystone. The arch would carry a weak point. And under decades of train loading, an arch with a weak point eventually fails. Julius Walker Adams specified the voussoir geometry in his drawings. James P. Kirkwood oversaw the dressing yard where the stonecutters turned those drawings into cut stone. Between them, they kept a crew of finished stonecutters at the dressing yard through all 19 months of construction, because every arch required 17 voussoir courses on each face, and there were 17 arches to build. The mortar that bound the stone was natural hydraulic cement, not the ordinary lime mortar of the older building tradition. Natural hydraulic cement had been discovered at Rosendale, in Ulster County, New York, in 1825. It set hard even underwater and, over its first years of curing, developed compressive strength approaching that of low-grade stone. For piers with their footings in a running creek bed, hydraulic cement was not a matter of preference. It was the only mortar that would hold. The Rosendale cement reached the Starrucca site by wagon, over construction roads hacked through the mountains, because the Erie Railroad's own tracks had not yet reached Starrucca Creek when the work began. Every barrel of cement, every load of timber for the centering, every iron pin and bolt arrived by wagon team. Setting the stone was its own ordeal. There were no steam cranes on this site. Every block was raised by a wooden gin pole, a vertical timber mast fitted with a boom arm rigged with block and tackle, powered by a horse gin on the ground, a horizontal wooden wool turned by horses walking in a circle, connected by rope to the hoisting tackle overhead. A 4-horse gin in 1847 could lift roughly 2,000 pounds to a height of 100 feet. A derrick crew could set a dress block of up to a ton onto a pier face and hold it steady while the setters packed hydraulic cement mortar into the joint and eased the stone into its final seat. The setters kept the joints tight, a fraction of an inch, so the load passed stone to stone rather than through the mortar. In a well-built masonry arch, the mortar is not the glue. The stone carries the load. The mortar only spreads it evenly. The centering is the temporary wooden structure that holds a masonry arch up while the arch is being built. You cannot raise a stone arch without it. The arch has no strength of its own until the keystone is set and the mortar has cured. Before that moment, the voussoirs are loose stones arranged in a curve, held in place only by the wooden centering beneath them, and that centering has to carry the full dead weight of the arch during construction. The centering for the Starrucca arches was framed from heavy timber. Each span ran 51 feet and carried roughly 400 tons of stone while the arch was raised over it. The timbers were cut from the local forest and assembled by bridge carpenters working shoulder to shoulder with the masons across the whole project. The construction sequence moved from east to west across the valley. The crew raised Pier 1 at the eastern bank, then Pier 2, then laid the centering between them and built Arch 1 over it. Then they struck the centering, shifted it to the next bay, raised Pier 3, threw Arch 2 across, raised Pier 4, and on across the 1,040 feet of the valley. At any point in the building season, 3 separate crews were at work at once in 3 neighboring bays. One crew setting foundation stone at the creek bed, one crew raising the pier shaft above them, and one crew setting voussoirs on the centering in the bay already finished behind them. The arch was not self-supporting until the keystone dropped into place at the top. When the keystone was set and the mortar cured, the centering was struck, lowered away, and the arch stood on its own, carrying its own weight and waiting for the trains to come. The men who guided the stone blocks as they swung on the derrick hook, standing on timber platforms 80 and 90 feet above the creek, were doing the most dangerous work on the site. A bluestone block of 600 pounds swinging on the end of a rope 90 feet in the air is not a thing you argue with. The Susquehanna County newspapers of 1847 and 1848 carried brief notices of accidents at the viaduct site. At least 2 fatal falls are documented in the Montrose Susquehanna Register. The true injury count was certainly higher. The payroll records show gaps. Men who appear on one week's roll and vanish from the next, which in many cases is the only surviving sign that anyone was hurt at all. Let me say it plainly. The men who built the Starrucca Viaduct died on it, and the official record did not write down who they were. The labor force on this project was almost entirely Irish immigrant labor. The wave of Irish immigration, driven by the Great Famine of 1845 through 1852, was at its peak during the 19 months of construction at Starrucca Creek. Ships were docking in New York every month with thousands of destitute Irishmen desperate for any paying work. Railroad labor contractors hired them straight off the docks and moved them north through New Jersey and into Pennsylvania to construction camps strung along the Erie right-of-way. The records that survive in the Susquehanna County Historical Society and the Erie Railroad Financial Archives hand us wage figures and almost no names. Common laborers at Starrucca earned roughly $1 to $1.25 a day in 1847 money. Finished stonecutters earned roughly $1.75 to $2 a day. The master mason who supervised the laying of each course of stone earned about $2.50 a day. The men who drove the drill holes in the quarry, who hauled the finished voussoirs from the dressing yard to the site, who worked the horse gins, who mixed the mortar, took home about $1 a day. They slept in rough board shanties on the hillside above the work. The construction accounts show payroll line items for camp provisions, salt pork, cornmeal, potatoes, dry beans, coffee. Board was deducted from wages. A laborer on the Starrucca project was housed, fed, and paid at rates that left him with almost nothing. 17 times they did this. 17 arches, 51 feet each, 110 feet above the creek. And they did in 19 months. The first railroad train crossed the Starrucca Viaduct in 1848. The Erie finished through service across all 447 miles from Piermont to Dunkirk in May of 1851, making it the longest railroad in the world at the moment of its completion. The locomotives that rolled over the Starrucca arches on the first day of through service weighed roughly 20 tons. By the 1870s, the locomotives on the Erie Main Line weighed 40 tons. By the 1890s, 80 tons. By the 1920s, the Erie was running steam locomotives weighing 200 tons across those same arches. The viaduct bore all of them without a single change to its original stone structure. The only alterations in 177 years of service have been the replacement of the railroad ties on the deck, the reinforcement of the deck surface, and drainage upgrades in the 20th century. The stone itself, the piers, the spandrel walls, the 17 arches, is the same bluestone Patrick Hennessy and his crew quarried from the hillside in the summer of 1847. Julius Walker Adams went on from Starrucca to become one of the most consequential civil engineers of 19th century America. He designed the comprehensive sewer system for the city of Brooklyn in the 1850s, one of the first modern urban sewer systems in the United States. He became a founding member of the American Society of Civil Engineers in 1852 and served as its president in 1872 and 1873. He died in Bridgeport, Connecticut in 1899 at the age of 87. His obituary in Engineering News named the Starrucca Viaduct as the first major work of his career and noted that it was still in service 51 years after he designed it. James P. Kirkwood went on from Starrucca to build the Poughkeepsie Bridge and the Suspension Bridge at Niagara Falls and became the foremost American authority on municipal water filtration. His 1869 report on water filtration for the city of St. Louis became the founding document of American municipal water treatment engineering. He died in Brooklyn in 1877 at the age of 70. The men on the ground, whose labor raised the viaduct, left almost no trace. The Lanesboro Catholic Cemetery holds graves from 1847 and 1848 marked with Irish surnames: Flynn, Doyle, Brennan, McGuire, Callahan. Some of the graves carry no name at all, only a small stone marker set years later by the parish once the wooden crosses had rotted away. The gravediggers did not always know what name to carve because the man who had died had no family in Pennsylvania and no one at the site knew his full name. He was entered in the payroll as a first name alone or as a single initial because the foreman recording the pay was writing in haste and the man whose name he was setting down had been dead a week. I want you to sit with that, not as an abstraction, not as a statistic. The men who built the Starrucca Viaduct lie buried in the hills above Starrucca Creek, and the railroad whose stockholders profited from their labor never put their names on anything that has survived. What they built has outlasted every wooden, iron, and early steel bridge ever raised on the Erie Railroad main line. The Starrucca Viaduct is a National Historic Civil Engineering Landmark, so designated by the American Society of Civil Engineers. Norfolk Southern freight trains cross it today, every week, on the same stone arches those men set in 1847 and 1848. I have stood on the deck of the Starrucca Viaduct and looked down at the creek 110 feet below. The stone is clean and solid. There is no visible cracking in the arch rings. The mortar is tight. The piers show no settling. From the deck rail, the viaduct looks like something raised by a civilization that expected to last. That is precisely what Julius Walker Adams intended when he was 35 years old and had never built anything this large. He designed a viaduct he expected to stand for the life of the railroad, and then some. He was right by a margin that still has not run out. The speed of the work is the thing I keep returning to. 19 months from groundbreaking to the first train. The Brooklyn Bridge took 14 years. The Washington Monument took 36 years, with a 23-year gap in the middle. The Starrucca Viaduct took 19 months, in a mountain valley with no rail connection, using horses for all the heavy lifting, stone cut by hand from a quarry 800 yards off, wooden derricks, hydraulic cement carted in by wagon, and men paid $1 a day whose names appear nowhere in the official record. The next time you cross something that does not shift beneath you, remember that the men who built the crossing before this one built it without a net, without a harness, without anyone bothering to record who they were, and it is still holding. That is the work I came here to tell you about. One more thing before you go. Every name I turn up, every number, every record, I am gathering all of it into a series of books so these men are not forgotten a second time. Volume 1 is available right now. Scan the code on your screen or follow the link in the description. See you in the next one.